on a clear night, far from city lights, and you'll witness a breathtaking spectacle, a luminous band of stars stretching across the heavens. This is our home, the Milky Way galaxy, a colossal island of stars, gas, and dust, a cosmic tapestry woven over billions of years. But have you ever wondered about its origin, its ultimate fate? And does this magnificent structure hold a deeper purpose in the grand cosmic scheme? Join us as we journey through time and space to uncover the incredible story of the Milky Way, the cosmic nursery, birth of a giant. Our story begins not with a bang, but with a whisper, a gentle gravitational collapse in the early universe, nearly 13 billion years ago. Before the Milky Way as we know it existed, there were vast, diffuse clouds of hydrogen and helium, the primordial ingredients of everything. These colossal clouds, many times the size of our future galaxy, were not perfectly uniform. Tiny fluctuations in density, mere ripples in the fabric of space, began to exert their subtle influence. Gravity, the invisible architect of the cosmos, started pulling these slightly denser regions inward. Imagine countless individual atoms drawn inexorably towards each other, slowly, patiently, like iron filings to a magnet. Over millions of years, these collections grew, forming even larger clumps. These were the seeds of protogalaxies, the embryonic precursors to the magnificent structures we see today. As these protogalactic clouds continued to contract, they began to spin, a natural consequence of conserving angular momentum, much like a figure skater pulling in their arms to spin faster. This early chaotic rotation was crucial. But the birth of our Milky Way wasn't a singular, elegant event. It was a violent, dynamic process of accretion and merger. Picture a cosmic ballet, not graceful, but a series of dramatic collisions. Smaller clumps of matter, nascent galaxies themselves, were drawn into the gravitational embrace of larger ones. As they merged, shock waves ripped through the gas clouds, triggering intense bursts of star formation. The early Milky Way was a messy, irregular shape, a far cry from the majestic spiral we observe today. It was a turbulent construction site, constantly being reshaped and sculpted by the relentless forces of gravity and the ongoing influx of fresh material. Each merger contributed its stars, gas, and dark matter to the growing galactic behemoth, gradually building up the mass and complexity that would eventually become our cosmic home. This violent adolescence was essential, forging the raw materials into the structure that would eventually house billions of stars, including our own sun. The dark matter scaffold. While we can see billions of stars, glowing gas, and shimmering dust within the Milky Way, these visible components represent only a fraction of its true mass. The dominant force shaping our galaxy, and indeed all galaxies, is an enigmatic substance we cannot directly observe: dark matter. Think of it as the invisible scaffold upon which the luminous structure of the Milky Way is built. Without dark matter, our galaxy simply wouldn't hold together. Its gravitational pull is what keeps stars orbiting at their observed speeds, preventing them from flying off into intergalactic space. Scientists infer its existence by observing these gravitational effects. For instance, stars in the outer regions of the Milky Way orbit much faster than they should if only visible matter were present. This discrepancy is strong evidence for an unseen, massive halo of dark matter encompassing our entire galaxy, extending far beyond the visible stellar disk. This dark matter isn't just a local phenomenon. It forms a vast, intricate cosmic web that permeates the entire universe. Imagine an enormous, three-dimensional spiderweb with invisible filaments stretching between colossal nodes. Galaxies like the Milky Way tend to form at the intersections and along these filaments, drawn by the enhanced gravitational pull of the concentrated dark matter. During the early universe, it was the clumping of dark matter that first provided the gravitational wells into which ordinary baryonic matter, the stuff we're made of, could fall. Without these dark matter seeds, the initial gas clouds wouldn't have had enough gravitational impetus to collapse and form the first stars and galaxies. So, while dark matter remains one of the universe's greatest mysteries, its role in the formation and ongoing stability of the Milky Way is undeniable. It's the silent, invisible backbone of our cosmic island. From globulars to disks, shaping the galaxy, the early Milky Way was a chaotic environment, a cosmic construction zone where gas clouds collided and smaller galaxies merged. But over billions of years, it began to settle into the familiar, majestic spiral structure we recognize today. A crucial player in this transformation was the process of disk formation. As the tremendous amount of gas and dust within the nascent galaxy continued to collapse under gravity, its rotation caused it to flatten out. Think of a spinning ball of dough that gradually flattens into a pizza crust. The material that retained more angular momentum settled into a thin, rotating disk, while some of the older, less organized stars and globular clusters remained in a more spherical halo above and below the disk. These globular clusters, ancient relics containing some of the oldest stars in the galaxy, offer invaluable clues to the Milky Way's early history, acting like fossilized remains of its turbulent past. Within this newly formed disk, gravity continued its work, but now with a more organized structure. Density waves, akin to traffic jams on a highway, propagated through the disk, compressing the gas and dust in certain regions. These compressions acted as triggers for star formation, giving rise to the beautiful spiral arms that characterize our galaxy. These aren't rigid structures, but rather areas where gas and stars momentarily pile up as they orbit the galactic center. As gas enters a spiral arm, it gets compressed, leading to the collapse of molecular clouds and the birth of new stars. These hot, massive and short-lived stars are incredibly luminous, illuminating the spiral arms and giving them their brilliant, bluish hue. Our own sun, a middle-aged star, resides within one of these spiral arms, the Orion arm, quietly completing its leisurely orbit around the galactic center, a journey that takes approximately 230 million years to complete. The central engine, Sagittarius. A star. At the very heart of our Milky Way, shrouded by immense clouds of gas and dust, lies a profound cosmic mystery, Sagittarius. A star, a supermassive black hole. This isn't just any black hole. It's a behemoth with a mass equivalent to over 4 million suns, compressed into a region smaller than Earth's orbit around our sun. While we can't directly see the black hole itself, its presence is revealed by the frantic dance of stars, orbiting it at incredible speeds. Astronomers have meticulously tracked these stellar orbits for decades, observing stars whipping around an invisible point, unequivocally proving the existence of an object with immense gravity concentrated in a tiny space. Sagittarius A star is the gravitational anchor for our entire galaxy, the focal point around which billions of stars, including our own, revolve. Its influence extends far beyond its immediate vicinity, shaping the dynamics of the inner galactic bulge. Don't let the term black hole conjure images of an insatiable cosmic vacuum cleaner constantly devouring everything in its path. While Sagittarius A star is undeniably powerful, it's actually quite dormant for a supermassive black hole. It occasionally swallows stray gas clouds or unlucky stars that wander too close, leading to brief flares of X-ray emission. However, compared to the active galactic nuclei found in some other galaxies, which furiously accrete matter and blast out powerful jets of energy, Sagittarius A star is relatively quiet. Nevertheless, its sheer mass and gravitational dominion are awe-inspiring. It represents the ultimate expression of gravity's power at the galactic scale, a silent, unseen titan at the core of our cosmic home. Its presence is a stark reminder of the extreme physics at play in the universe, where even the most fundamental forces can lead to such magnificent and mind-boggling phenomena. Our place in the cosmos, the sun's journey. Within this grand tapestry of stars, our own sun, a seemingly ordinary yellow dwarf, embarks on an epic journey. It resides about 2/3 of the way out from the galactic center, nestled within the Orion Arm, one of the Milky Way's prominent spiral features. Our entire solar system, with all its planets, asteroids, and comets, is caught in this cosmic merry-go-round, orbiting Sagittarius A star at an astonishing speed of approximately 230 kilometers per second. Even at this incredible velocity, a single complete orbit, known as a galactic year, takes an astounding 230 million Earth years. To put that into perspective, the last time the Sun was in its current galactic position, dinosaurs still roamed the Earth. This constant motion is a testament to the dynamic nature of our galaxy, where every star is a traveler on an immense, cyclical path. The Sun's journey through the Milky Way isn't a solitary one. It's accompanied by billions of other stars, all influenced by the galaxy's gravitational pull. As our solar system orbits, it sometimes passes through regions of higher gas and dust density within the spiral arms. These encounters can potentially stir up the Oort cloud, a distant reservoir of icy bodies at the edge of our solar system, potentially sending comets hurtling towards the inner planets. While these events are rare on human timescales, they highlight the subtle ways our galactic environment can influence our local neighborhood. Understanding the Sun's position and movement within the Milky Way is crucial for unraveling the history of our galaxy and even for assessing the long-term habitability of our planet. Our little corner of the cosmos is not static. It's an active participant in the grand ballet of galactic evolution. The purpose of a galaxy, a stellar crucible. Does a galaxy have a purpose? In a strictly teleological sense, perhaps not. The universe doesn't seem to operate with predefined goals for its structures. However, if we consider purpose as a function or a role in the cosmic ecosystem, then galaxies like the Milky Way have a profound and indispensable one. They are the universe's stellar crucibles, the grand factories where stars are born, live and die, and where the very elements essential for life are forged. Without galaxies, the vast clouds of gas and dust would likely remain diffuse, never collapsing to ignite the nuclear furnaces of stars. Galaxies provide the gravitational framework, the density enhancements, and the conditions necessary for star formation to occur on a massive scale, transforming simple hydrogen and helium into a rich tapestry of heavier elements. Furthermore, galaxies are the engines of cosmic enrichment. The first stars in the universe were composed almost entirely of hydrogen and helium. It was only through their life cycles, particularly the violent deaths of massive stars as supernovae, that heavier elements like carbon, oxygen, iron, the very building blocks of planets and life, were created and dispersed into the interstellar medium. Each generation of stars enriches the galaxy with these vital elements, leading to the formation of subsequent generations of stars and planetary systems that are increasingly metal-rich. Our own Sun and Earth are second-generation, or even third-generation cosmic products, benefiting from the elemental contributions of stars that lived and died billions of years before our solar system even formed. So, while not a conscious purpose, the Milky Way's fundamental role is to recycle cosmic matter, create new stars, and provide the environment for the synthesis and distribution of the ingredients necessary for chemical complexity and ultimately for life itself. Galactic cannibalism, the Andromeda Collision. The Milky Way, while vast and seemingly eternal, is not immune to the gravitational dance of the cosmos. In fact, it's on a collision course with its largest galactic neighbor, the Andromeda Galaxy. This isn't a hypothetical future, it's a cosmic certainty, predicted by meticulous observations of the galaxy's movements. Andromeda, A massive spiral galaxy, even larger than our own, is currently hurtling towards us at approximately 110 kilometers per second. Don't panic just yet. This spectacular cosmic event is still about 4.5 billion years away. When it does occur, it won't be a head-on crash in the way two cars collide. Galaxies are mostly empty space, vast expanses between stars. So, individual stars are unlikely to directly collide. Instead, the gravitational forces will begin to tug and distort both galaxies, like two colossal whirlpools merging. Over hundreds of millions of years, the two galaxies will pass through each other multiple times, their gravitational fields ripping apart their elegant spiral structures. Gas clouds will be compressed, triggering intense bursts of star formation, creating a brilliant, if chaotic, spectacle across the newly forming galactic landscape. Eventually, after perhaps 1 billion years of this cosmic dance, the two spirals will coalesce into a single, larger, more elliptical galaxy. This new galactic entity has even been given a name by astronomers: Milkomeda. Our Sun and solar system will likely survive this merger, though our view of the night sky will be dramatically different, filled with the stars of two merged galaxies. This galactic cannibalism, as astronomers sometimes call it, is a common process in the universe, with larger galaxies often consuming smaller ones, leading to the growth and evolution of these magnificent structures over cosmic time. The expanding void, isolation, and decay. While the Andromeda Collision will dramatically reshape our galactic neighborhood, a far more profound and inescapable force is at play across the entire cosmos: the accelerating expansion of the universe. This expansion is not just moving galaxies away from each other, it's stretching the very fabric of space itself. In the unimaginably distant future, billions and even trillions of years from now, this expansion will have a profound effect on our post-merger galaxy, Milkomeda. As the universe continues to inflate at an ever-increasing rate, all other galaxies outside our local group, the small cluster of galaxies, gravitationally bound together, including the Milky Way and Andromeda, will recede beyond the observable horizon. They will move away from us faster than the speed of light, not because they are physically traveling faster, but because the space between us is expanding so rapidly. Milkomeda will eventually become a solitary island in an ocean of cosmic darkness, unable to see any other galaxies. The light from distant galaxies will simply never reach us. Within this isolated future galaxy, the processes of star formation will slowly grind to a halt. The available gas and dust, the raw material for new stars, will gradually be used up or blown away by stellar winds and supernovae. The brightest, most massive stars, with their short, fiery lives, will have long since died out. All that will remain are the long-lived, dim red dwarf stars, slowly burning their nuclear fuel over trillions of years. The once vibrant galactic landscape will grow increasingly dark and quiet, a monument to a bygone era of stellar birth. It's a sobering vision of cosmic solitude, where the vast, glittering universe we know today will have largely faded from view, leaving behind only the ghosts of galaxies. The last star, a fading ember. In the unimaginably distant future, long after the Andromeda-Milky Way merger and the complete isolation of Milkomeda, the universe will continue its inexorable march towards entropy. Trillions upon trillions of years from now, even the most resilient stars, the long-lived red dwarfs, will begin to exhaust their nuclear fuel. These small, cool stars burn so efficiently that their lifespans can exceed the current age of the universe by orders of magnitude. But even they are not eternal. As their hydrogen supplies dwindle, they will eventually shrink and cool, transforming into faint, cold, black dwarfs, theoretical stellar remnants that no longer emit light or heat. This will be an incredibly slow, drawn-out process, unfolding over periods that dwarf our understanding of time. Imagine a single, barely visible ember, slowly fading into complete darkness, a final farewell to stellar luminosity. With the demise of the last stars, the galaxy will plunge into an era of profound darkness. The only light will come from the occasional collision of stellar remnants or the very faint glow of decaying protons, another theoretical process. Over timescales truly beyond human comprehension, even the black holes themselves are predicted to evaporate through Hawking radiation, slowly leaking their mass back into the universe as elementary particles. The final fate of the Milky Way, as part of Milkomeda, aligns with the ultimate fate of the entire universe: heat death. This isn't a fiery end, but rather a slow, cold dispersal of all energy and matter, reaching a state of maximum entropy where no further work or processes can occur. The once vibrant, bustling galaxy will become an almost infinitely diffuse collection of elementary particles, spread across an endlessly expanding, cold, and dark void. Echoes of brilliance, the cosmic legacy, the ultimate demise of our Milky Way, billions of years in the future, sounds like a bleak conclusion. However, the story of our galaxy, from its chaotic birth to its eventual fading, is not one of futility. It's a testament to the incredible dynamic processes that shape the cosmos. The Milky Way has served as a stellar crucible, forging the elements essential for life, nurturing billions of stars, and providing a home for diverse planetary systems, including our own. It has been a stage for cosmic evolution, a laboratory for the laws of physics, and a source of wonder and inspiration for countless generations. Even as it fades, the legacy of its existence will endure in the fundamental particles that once comprised its stars, planets, and perhaps even its sentient life. And while our galaxy's final end is unimaginably distant, its present beauty and complexity serve as a powerful reminder of our place in the universe. We are living in a precious moment, capable of observing and understanding this magnificent structure, a privilege that may not last forever. The Milky Way's journey, from nascent gas cloud to solitary remnant, is a grand narrative of cosmic forces at play, a story that continues to unfold above us every clear night. So, the next time you look up and see that shimmering band of stars, remember its incredible past, its vibrant present, and its long, slow journey towards an inevitable, yet still awe-inspiring cosmic